GPS trackers have been around for a while, and about every 6 months another one pops up with a slightly different angle. This time it's tracking luggage. Previously it was tracking your grandma or your pet. The new fad is for Bluetooth tags, and whilst there's a niche for everything, trackers have failed to make the mainstream of consumer devices, not because of their lack of interest, but because they've all failed to meet one or more of what we have identified as the 5 key issues. Number 1, poor battery life. The time between charges is usually measured in hours, not days. Number 2, high cost. They're expensive to use. Usage is rarely unlimited and varies considerably by country. Number 3, unreliable location fixes. GPS technology is fantastic, but it doesn't actually deliver locations indoors, which can amount for up to 50% of the time. Number 4, global solution. Most solutions work well in one or more countries, but they don't work well in every country. And number 5, difficult to use, often involving sending commands via SMS. Our philosophy has been to create a generic location device that addresses these issues that you can then configure to meet your needs, whether that's keeping tabs on your luggage or your loved ones. The number one reason why adoption is low is battery life. So we set out the objective of achieving 1 month between charges. The way that we do this is by switching off when not sending location events. This is not a standby mode. This is turning off everything but a small countdown clock which consumes around 60 microamps. You can also configure the accelerometer to wake the device up. It costs around 2 milliamp hours of battery each time a location update is sent. This means that you get to send around 350 location updates on a single charge. You can choose to send these all in one day, or you can configure the transponder to only send updates every hour or every day. Furthermore, you can also specify whether you want updates during the night or even just on a certain day like every Monday. So a typical configuration might be to send updates every day between 8 AM and 10 PM at intervals of 1 hour, unless the device is moved. All trackers use mobile data or SMS to send the location events to you. The problem is that the costs associated with these services varies considerably by country, and so offering a global service with unlimited usage is very expensive and would usually involve a commitment of at least a year. USSD stands for Unstructured Supplementary Data. It's a GSM network protocol just like SMS, and is used to send small amounts of information between devices. The big difference with SMS is that USSD is a connection-oriented protocol, just like mobile data. You send stuff and you get an instant response, whereas with SMS you have to wait until someone sends an SMS back to you. With USSD, it's possible to offer a truly global unlimited service. So why don't all GPS trackers use USSD? The answer lies with how GPS works. For a GPS receiver to get a location fix, it has to know how far it is from at least 3 satellites. This is called trilateration. The distance information is continually output by each satellite in the form of a timestamp. The time difference between transmission and reception by the GPS receiver, multiplied by the speed of light, gives the distance. In GPS speak, this is called a pseudo-range. But there's a problem. The GPS receiver may know how far it is from a satellite, but it doesn't know where that satellite is. The ephemeris data allows the GPS receiver to calculate a given satellite's position at a given time. However, the ephemeris data is only valid for a couple of hours, so it needs to be continually refreshed. If the tracker is always on, this just happens. But if the device switches off to conserve power, to get to the 1 month battery life, then the ephemeris data must be downloaded each time the device wakes up, and at a rate of 50 bits per second, this can take several minutes. Mobile data, also known as GPRS, solves this problem by allowing the ephemeris data to be downloaded much faster via the internet using something called an AGPS server, where the A stands for assisted. So with USSD, we solved the cost issue, but the time to get a fix is too long, which is why it's not used for GPS trackers. We have solved this by only capturing the pseudo ranges and sending these to the server via USSD, and the server then doing the calculations using server-side ephemeris data. This means that the transponder can get a fix from a cold start in 15 seconds with no network assistance anywhere in the world. If you've made it this far, you'll understand the transponder is a GPS tracker that uses USSD, not mobile data, enabling a long battery life and a truly worldwide service. But what about when you go indoors? There's no GPS inside buildings. When I use my smartphone to get a location fix, I'm holding the device in a specific orientation. No such luck with a tracker. It has to work even buried at the bottom of a bag or suitcase in the boot of a car. So how does the transponder get a location fix in these kinds of everyday situations where a GPS tracker often simply fails? The answer is GSM and Wi-Fi. Of course the transponder supports GPS, but it also uses the mobile phone network's cell tower location to provide a more approximate location fix when GPS is not available. And uniquely, the transponder can also detect Wi-Fi base stations, just like your smartphone, and use these to provide a location fix even when you're indoors. If you look at the small print for any other GPS tracker offering a worldwide solution, what they really mean is that it will work in those countries that offer mobile data at reasonable rates. Usually this means North America and Europe are fine, but if you venture further afield, you may find that either your global solution doesn't work at all, or you incur some eye-watering mobile data charges. As the transponder works using USSD, it's easier to state which countries the transponder is not supported in. So currently, it won't work in Antarctica, Diego Garcia, Eritrea, Lesotho, San Marino, Nauru, South Sudan, and Swaziland. It works pretty much everywhere else. We looked at the way trackers were configured. This ranged from having to send SMS message to configure and view locations by clicking on an SMS link, to smartphone apps that try to offer an oversimplified solution. Because we've been customers as well as engineers, we've developed an app that gives you complete control over everything. Once you've configured the transponder, you can configure how and when you get notified of location events. It also allows you to share your transponder location information with other people via a public mode, and even to send location updates to your Twitter account. To make sure this functionality was robust, we've developed a version of the app that also allows you to turn your iOS device into a virtual transponder. This was launched in January 2014 on the Apple App Store, and has an active user base of 2,000 users. The basic mode of operation is as follows. The transponder either wakes up because it has detected movement, or after a configurable time period has elapsed. It gathers all the location information and sends it via USSD to the server. The server then calculates the transponder location and checks on how the user wants to be notified. Apple Push Notification is enabled by default for iOS devices. But email and Twitter are also supported. The transponder itself is designed to be dumb. It has a micro USB port for charging, a recessed switch if things go wrong, and an LED to show it's on charge, and that's it. It's water resistant, and the one-piece moulding means it's also strong. Basically, you can simply put it where you want and then forget about it. So in summary, the poor battery life has been addressed by giving you complete control over how your 350 updates are sent. The high cost is addressed by having a very low flat rate, monthly flat rate, with unlimited updates. The unreliable location fixes with GPS only are addressed by including GSM and Wi-Fi. And using USSD, we're able to offer a truly global solution. And finally, the ease of use is addressed through the smartphone apps, which gives full control of the transponder, as well as loads of features like public mode, Twitter integration, and breadcrumb trails. iOS and OS X apps are deployed on the Apple App Store and have been in production for 9 months and currently support an active base of 2,000 users. There's a universal HTML5 client in development. The transponder is CEE approved with FCC approval pending. The transponder has been through extensive worldwide field testing over the last 18 months, and we are now ready for the first volume production run. The more commitments we get, the cheaper the transponder will become, as the initial cost is driven solely by volumes. All manufacturing is UK-based, and all the development has been done by Rat Lake Technologies, which owns all the intellectual property associated with the systems.